Hi, 7th grade. Today we are going to do two lessons, lessons 4, 5, and 4, 6. So we'll start with lesson 4, 5, add expressions. By the end of the lesson, I want you to be able to say, I can add expressions that represent real world problems. All right, to save time, since we want to fit two lessons in, we are going to skip this first page and go right to the first example. Add expressions using properties. Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? So she's going to two different places. Rudy's Rock and Climbers is $65 initially. So she starts with $65, and then they charge her a $40 monthly fee. So that $40 happens every M months. We don't know how many months there are, so we keep the variable M. Then the ACE Health Club charges her initial fee of $80 and a monthly fee of $50. We don't know how many months again, but it's the same amount of months she's going to the rock climbing, so we can use M again. So that's that 50M. And already you can see my different colors are the like terms. We can use the commutative property to change the order. 80 plus 60, 5, and 50M plus 40M. Well, 80 plus 60 is 145, and 50 plus 40, is 90. So the expression 145 plus 90M can be used to determine the total cost for the health club and rock climbing gym after M months. Let's try it. Sophia and Ollie each deposit $120 to open a joint account. They each make monthly deposits as shown. What expression represents the amount in the account after M months? Well, they both put $120 down first. So they're both starting with $120. Then Sophia deposits $150 every month. So that's going to be 150 times M. Ollie deposits $135 per month. So she deposits last. All right, let's combine like terms. Our constants, remember constant is just a number. So that's 120 plus 120. And then we'll combine our M's, 150 and 135. Remember, the commutative property tells me I can change the order of the numbers and still get the same answer. So 120 plus 120 is 240, and 150 plus 135 is 285M. Explain why the initial deposits and monthly deposits are not combined into one term. Well, you can't combine 120 plus 150M because they are not like terms. The 120 only happens once, whereas 150 keeps happening over and over depending on how many months they use it. Example number 2. Add expressions with more than one variable. Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. So she makes $240 on a muffin. So no matter how many muffins she sells, that's going to be M. But we have to subtract the cost of ingredients for the muffins. Same thing with her bagels. She makes $1.80 every bagel, but we need to subtract the cost of buying a bagel. To find her total profit, we are going to add these two expressions together. 240M minus 125 plus 1.80B minus 9240. Looking here, I know I can put my two constants together, but I can't combine the M and the B. They are not like terms, so they just keep following down, and they'll be part of the final answer. But negative 125 minus 9240 gives us negative 217.4. So the expression 2.40m plus 1.80b minus 217.4 represents the profit from selling the muffins and bagels. Example 3, add more complex expressions. So we're adding the expressions 1/2 x minus 3 minus 2y plus 1/4 x minus 2y plus 5. So our first step is to combine like terms. I know my 1/2 x plus my 1/4 x go together because they both have an x. My -3 and, careful, -3 is a constant, so I'm going to circle the other constant, +5. And last but not least, -2y with -2y. So now that I've used the commutative property to join them all together, I can add 1/2 plus 1/4 is 3/4 because 1/2 is equal to 2/4. So 2/4 plus 1/4 gives me 3/4. Then -2y plus -2y is -4y. And -3 plus 5 is 2. So here's our final answer. Find each sum. So we're looking for our like terms. I've got a constant here and a constant here. Remember to circle the signs as well. 9.74 has a C on it, and -5.48 has a P on it. So we don't combine those with anything, so I'm going to rewrite 9.474C minus 5.48P. And now I'm going to combine -250.50. So I get out my calculator. -250.50 plus 185.70 gives me -64.8. All right, on to the next one. I've got a 2/11x and a -3/11x. I've got a -3 and a +5.5. And then I have a -5y and a +5y. So 2/11x minus 3/11x, that's going to give me -1/11x. -3 plus 5.5 gives me -2.5. And then -5y plus 5y, those are opposites, so they just cancel each other out. Next, we have -14.2b, but there are no other b's. We have -97.35, that's a constant. So I underline my other constant, -118.7. Then I've got 6.76d and -3.4d. So I'm going to rewrite -14.2b because there's nothing to combine it with. Then I take out my calculator, I do 97.35, -97.35 plus 118.7 to give us a +21.35. And then combine the d's, 6.76 minus 3.4 gives us +3.36d. All right, last but not least, I have 3/8 is my constant, can add it with 1/4. And I have a -1/6m with 7/10 m and a +5t with a +9t. So 3/8 plus 1/4, I want to do that first. 3/8 plus 1/4. I can't combine these yet because they don't have common denominators. So my common denominator would be 8. So it's going to be 3/8 plus 2/8, which is 5/8. So I've got 5/8. Then same thing, I've got a -1/6 and I want to add 7/10. So my common denominator would be 30. So I'm going to multiply this by 5 multiply this by 3. So that gives me negative 5/6 plus 21. Oop, negative 5. Hopefully someone caught that. Negative 5 over 30 plus 21 over 30. So negative 5 plus 21, equals positive 16 over 30. And that is m. And then 5t plus 9t equals 14t. Okay, next we are going to go to the next page, lesson 4.7, subtract expressions. I can subtract expressions using properties of operations. So, example 1, subtract expressions using properties. Lita's family wants to put the tile border around their swimming pool. What expression represents the total area of the border? So area is length times width. So we're doing the area of the pool and the tiles, the whole thing, minus the area of just the pool. So the area of the pool and the tiles is 18 times 2x plus 18. And then the area of just the pool is 14 times 2x plus 14. So first we distribute, and they did that for us. 36x plus 324 minus 28x minus 196. Same thing we were just doing, combine like terms. 36x goes with negative 28x. 324 goes with negative 196, keeping in mind the signs, and solve. A frame holds a picture that is 15 inches long and x inches wide. So we've got 15 and x. The frame border is 3 inches around. So this adds an extra 3 inches. What expression represents the area of the frame border? So we have to find the area of the whole thing and subtract the area of the picture. So length times width, the area of the whole thing is going to be 15 plus x times, not 15 plus x, 15 plus 3, which 15 plus 3 is 18. So that's the length, 18 times x plus 3 minus the area of the picture is just length times width, 15x. So I'm going to distribute. So 18 times x is 18x. 18 times 3 equals 54 minus 15x. So we're going to fill this in our boxes. 18x plus 54 minus 15x. I can combine like terms. 18x minus 15x gives me 3x plus 54, which we can't combine anymore because they are not like terms. So that is our answer. Why can you choose to add or subtract when subtracting an expression? Because adding a negative is the same as subtracting. Okay, you can take a look at example number 2 on your own. They set up the equation. If you're subtracting the whole thing, it's like a -1. You want to distribute the -1 to everything inside. So let's try it. This is technically a -1. Distribute that in. We rewrite this as 0.95x minus 0.04 minus 0.99x. And now a negative times a negative is a positive 0.13. Combine like terms, and you'll be able to solve that on your own based on what we've already practiced. Same thing happens for example 3. Distribute the negative, and you will be able to solve. Try that on your own and check your answers with me. We don't have enough time to say it, so say it yourself in class.